Hello and welcome to this tutorial about scaling a processing parameter file, often called a PRM file. Our objectives here are first to understand the reason for scaling a PRM file, then to learn how to do it, and finally to see the results in a simulation. Let's assume for this exercise that we have run several test prints of a part using the Inconel 718 material and measured a peak distortion of 0.4 millimeters along the external face. We're going to simulate this build in Netfabb simulation utility and see whether the simulation results are close to the experimental results. If not, we'll know that the PRM file we used is not going to produce accurate results in other simulations with Inconel 718. To correct this issue, we can scale the PRM file and see whether it will produce displacement results more in line with actual test results. In the simulation utility, we follow the standard process to create a new simulation. And open the file example19.stl. In the import dialog, we click Part and OK. Then in Converted Model Units, also click OK. And the STL file is imported on a build plate. On the Home tab, we click Machine. Then in the Machine dialog, select the PRM file for Inconel 718 and click OK. Click Build Plate, and then on the Properties tab, deselect Match Part Deposition Material and select SAE 304 for our build plate material. Under Thermal Conditions, Heating, select Controlled Temperature and set the temperature value to 160 Celsius. With that set, we next click Mesh Settings, and in this dialog, change the meshing approach to layer-based. Here we also change coarsening generations to 1 and layers per element to 5. Now we are ready to run the simulation, so click Solve. When the results are available, we load them. Note that the Results tab opens automatically. Make sure that the displacement results are selected, and then click Plot Settings. In this dialog, we set the component value to X. Click OK, and then walk through the results looking for peak displacement. We find this just before the build plate is removed. But the peak value is 0.17 millimeters, much lower than the experimental results of 0.40 millimeters. So we're going to see if we can make the simulation results more realistic by scaling the PRM file. We go back to the Home tab and click Processing Parameters. Select the Inconel 718 PRM file that we used before and click the Scale button. Now we need to settle on a scale factor value. Let's try a simple linear value obtained by dividing measured distortion by predicted distortion. In this case, 0.40 millimeters divided by 0.17 millimeters produces a scaling factor of 2.35. Enter that value and click OK. The scaled PRM file is added to the PRM library at the bottom of the list. You can see that the word scaled has been appended to the file name. Now we click Machine and select the scaled PRM file for our next simulation. No other settings are changed, so we click Solve and approve the overwriting of previous results. When the results are available, load them as before. Ensure that displacement results are selected. Click Plot Settings and set the component value to X as we did before. Now when we find the peak displacement value, It is 0.39 millimeters, very close to the measured results of 0.40 millimeters. So this scaled PRM file appears ready to use in other simulations within Canal 718, producing accurate predictions of displacement. If additional results are analyzed, it's possible to revise the scale factor for improved simulation accuracy.